Okay, I'm going to talk about binary covalent compound nomenclature. So covalent compounds can get pretty complicated. That's why I'm going to focus just on binary, okay? When you get to more complicated ones, you can have different systematics. So we will also look at acids in another video. We won't go into things like organic compounds right now. But binary covalent compounds, you need to kind of understand first what that is before we go into the nomenclature or the interconversion between the chemical formulas and the names. So first off, a binary covalent compound or a binary molecular compound, that's interchangeable, covalent, molecular, that terminology is the same. Um, these things consist of two nonmetal elements. So be very careful. I said two nonmetal elements, not two atoms. Um, and so you've got two different elements. You can have multiple atoms of each, or one of each, whatever. So the ratio is dependent on what elements you're dealing with. And even when you have a certain pair of elements, they can sometimes combine in multiple ratios. So specifically, I've got here carbon and oxygen, okay? So carbon and oxygen can combine in a ratio of 1 to 1 or 1 to 2, okay? And those are two totally different compounds. So you have carbon monoxide and carbon dioxide. Those are very different. Um, it's simple in the sense that they only contain two elements, okay? But since they're the same two elements in both compounds, we have to use more than just the element names to come up with a naming system for them. We have to tell you how many things we have in order to definitely tell you which compound we're talking about. Another example I have here is with sulfur and oxygen. Sulfur and oxygen commonly combine in a 1 to 2 or a 1 to 3 ratio to form binary covalent compounds. Now be cautious because sometimes people see SO2 and SO3 and they think, oh, we're talking about some oxoanion. These, notice, do not have charges on them. So these are not anions. They're not polyatomic ions. Now, yes, sulfur can combine with oxygen and form an anion. So can carbon. But right now, we're not talking about ions. Covalent compounds are not ions, okay? And they aren't made up of ions. Covalent compounds have individual molecule units, and overall they are neutral and they're bonded together by covalent compounds. And when we write the chemical formula, what we're really writing is what we call the molecular formula, okay, which tells us the actual number of atoms present in a given molecule of that substance, okay? So it is different from ionic compounds. Ionic compounds, you write the formula unit of the substance, okay, the lowest ratio of ions, which you could also call the empirical formula when you're representing ionic compounds. But for covalent compounds, we write the true formula, the molecular formula, and it tells us the molecule, what the molecule is made up of. But let's jump into the actual nomenclature of these compounds. Um, so like a lot of other nomenclature, there really is a systematic to it. And so you can think of it as kind of a step-by-step process to convert between formulas and names, names and formulas, okay? And so if we want to put this into kind of some steps, what you need to do is first, you need to name the elements. Oh, lost light. Here we go. Okay. So first you name the elements. So if you were given a chemical formula, so that's the way I'm going to present this. If you're given the formula of a binary covalent compound, how do you name it? So name the elements. So if I had like CO or I had CO2, then carbon and oxygen. Okay, so that's where we would start. Um, and you name them in the same order as the formula has them written. So since CO and CO2 are written with carbon first and oxygen second, the first part of the name is going to have carbon, the second part of the name is going to have oxygen. Okay, and then we will add to this. Okay, so the next step is to place a prefix on each to indicate the number of atoms of that element. Okay, and I give you a list of the first 10 prefixes, and that's more than enough. You don't need more than that. Okay, and these prefixes should, most of them be fairly familiar, because these are common prefixes that even are used like in math, describing shapes and things like that. So 1 is mono, 2 is di, 3 is tri, and so on. And so you need to apply those prefixes to the name. Okay. There are a couple of changes to this. So you don't place mono on the first element ever. Okay. So if you do have only one of the first thing, you don't say mono of that. So you see that in like carbon monoxide, CO, it's carbon and oxygen. You don't say monocarbon. And so you drop it off the first one, but we do say monoxide. So you put it on the second. So that's the only prefix that you completely drop ever. Okay, you drop it, or maybe I shouldn't say that. There is one other case where we drop stuff. But in general, it's first element, you can drop the mono. You shouldn't be dropping it elsewhere. One other thing with these prefixes is notice they all end with vowels, right? And when you have soft vowels along with other soft vowels, that in English is kind of a weird thing, and so usually we get rid of extra vowels. When I say soft vowels, it's A's and O's, so I is a hard vowel. You don't drop I's ever from things. But if your element name that you're tacking this prefix on starts with an A or an O, then you would drop the A or the O from the prefix. Okay, so when I say monoxide, I'm dropping the O from mono. I'm not saying monooxide. And so you just don't double up those letters. Now, that's kind of a nitpicky thing. Technically, it's not proper to leave in the extra vowel. But, if you leave it there, it's not going to really hurt anything too much. People are going to know what you're talking about. They're just going to know that you're not very good at this. And that's okay. But like I said, pretty much the prefixes you're going to put on everything, unless if it's the first element, you drop mono. There is one other case when you have elements that only combine in one possible ratio, then they'll drop the prefixes altogether. That really is only the case, at least for common things that you would run into for halogens. And really it applies to hydrogen with the halogens. And so you could have, HF, HCl, HBr, and HI, and there's no other possible ratio. So instead of saying hydrogen monofluoride, you would say hydrogen fluoride, if you were talking about it as a binary covalent compound. But those are ones that we usually don't talk about too much in the form of a covalent compound. Those actually can get clustered with acids more often. So I would stick to these things that I've got here on this slide and not worry about the rest. Okay, so once you've done that, there's one other part that maybe you've already caught when I've said these names, but the last part is to change the ending of the second element to "ide." Okay, so notice when I say, CO is carbon monoxide, I don't say that it's carbon monoxygen, right? So I change the ending of oxygen to "ide" in that case. And you would do that for any element, okay? And you only do it on the second don't do it on the first one as well. Okay. So kind of the key is any binary covalent compound, the name of it is always going to just tell you which two elements you have, and it's going to tell you how many atoms of each you have, okay, by using those prefixes. And it has that "ide" ending always. So let's look at some examples of this. Also, I guess I should mention, I presented this as naming them from a formula. You can also take the name and convert it to a formula, but once you know how to name them, going backwards should be very easy. It should actually be way easier. Once you have the name, you just need to write down the symbols of the elements and put subscripts based on the prefix given. So the reversal of this should be pretty easy. So let's look at some examples. So if we had P2Cl4, you would name the two elements. So you have P is phosphorus and Cl is chlorine. Okay. And the second one, we change the ending to "ide." Okay. So that's why I have it written as chlorine and then chloride. And those go together and you put prefixes on each. Okay. And so instead of just phosphorus, I say diphosphorus because there's two of them. And instead of chloride, I say tetrachloride, okay, because there's four of them, and that is the prefix for four. And so that's the process. And so you can kind of flip the order. I guess technically I flipped the order a little here, but you have to have all those pieces, okay? Come up with a system that works for you that follows all of these guidelines. This should be actually easier than ionic nomenclature. Because all you really need is to know element symbols, which you already need to know for everything else. And you need to know these 10 prefixes, which most people know a good chunk of them just from other things. Okay, another one, N2O. There we've got nitrogen and we've got oxygen, and oxygen will change to oxide to get that "id" ending on the end. And then we say how many each. So we have two nitrogens, so it's dinitrogen. We have one oxygen, so it's monoxide. And so there, that's where you'll see I've dropped a vowel. And so it's not monoxide. You don't put a double O there. And if you did, it's not the end of the world, but it's technically not. Now, next up, I've got SO3. And so that is sulfur and oxygen. And the oxygen I would change to oxide. And then if you put those together and put prefixes, you have one sulfur, but remember you don't put the mono prefix on the first. So that's why I still just have sulfur in the overall name. And then the second one, you've got 3, and so it's trioxide. And so that's the basic, step-by-step figuring these out. I guess I've got a few more that I'll go through here. I've got S3Cl2, and so we've got sulfur, and we've got, we had oxygen just in the last one, chlorine. Okay, sulfur and chlorine. And so with that, I've got 3 sulfurs, and so 3 is going to be tri, right? And 2 is going to be di, and so I need to put that stuff together. And so then it would be trisulfur, and then dichloride, so not just chlorine, it would be dichloride. Okay. And then next one, so I'll go ahead and erase this. So there's that answer. So the next one, I've got sulfur and oxygen, so maybe I'll write that over here, sulfur and oxygen. The sulfur, I have a prefix of di, and the oxygen is going to be mono. Okay, and so I'm going to put all of that stuff together and put an "ide" ending. So it would be disulfur. It would be monoxide. Okay, so I changed the oxygen to oxide. And then the last one, I've got sulfur again. And then I have fluorine. And there's one sulfur. But since that's the first one, we don't put a prefix. So I won't put any prefix for that one. The second one, it's 6, so it's hexa. So I put all of that together and it would give me sulfur hexafluoride. Because remember, I changed fluorine to fluoride. We put that ID ending on all of these binary covalents. Okay, so that should be hopefully enough to get you started at least, get you to understand this. So you should be able to reverse all of these, but the reversal for binary covalence usually is a little more obvious for people, because you just need to convert names to element symbols and then make those prefixes into subscripts. Okay. Okay, so that's binary covalent compound nomenclature.